Regarding slopes, I think it is a helpful distinction to think about grand slope versus simple slope. So the grand slope is simply the relationship between x and y across all units in the sample. So not even considering a moderator, what is that main effect of the predictor and the dv? What does that relationship look like? That would be the idea of grand slope. A simple slope, on the other hand, is the relationship between x and y at a certain part of the moderator. So for example, at high levels of the moderator, what does this relationship look like? And that would be a simple slope. So really what we're doing in moderation is we are taking our moderator and disaggregating it into various clumps. And we're going to check out that simple slope at each one of the clumps. So we can, for example, break up a continuous moderator in a few ways. We could do a dichotomous kind of thing where we take a mean split and look at the high versus low. We could split it into three, a high, medium, and low, or high, mean, and low. So those are the things we could do with the continuous. With the categorical, we look inside the groupings. So for example, if gender is the moderator, we look at the relationship between x and y separately for men versus women. And those would be simple slopes. We could also look across organizations. Let's say we have 5 organizations and we expect that a relationship between x and y will differ depending on which organization we're looking into. And so those are simple slopes. The relationship between x and y inside just organization number 4, for example, is a simple slope. So I think the simple and grand is a nice distinction when thinking about slopes. In the SPSS output, if you're looking for the change in Rsquared as a result of adding the interaction term, you would go to the model summary table, and you would go to the block that contains the interaction, probably the second or third, and you would head over to the rightmost column where it says F significance, and you would see if that term is adding a significant bump in Rsquared. So if it's 0.05 or below, then you would know that it is. What is the difference between type 1 and type 2 homoscedasticity? Well, this is very similar actually to the simple slope and grand slope distinction. Type 1 homoscedasticity means that for the full sample aggregated across all levels of the moderator, everybody in the sample, we would expect the diffusion of residuals around the best fitting line to be consistent across all levels of the predictor. However, for type 2 homoscedasticity, we would expect that the simple slopes inside each of the groups of that moderator would have a similar distribution of residuals around the best fitting line. So type 2 homoscedasticity only is an issue when we have a categorical, IV, or moderator. If we have 2 continuous variables interacting to impact the dV in some way, then we don't have to worry about this particular assumption. But type 2 is always the case when we have a categorical predictor that is interacting with a continuous one. So that is a trigger to you. If you see an exam item that asks you things to consider or steps to take when analyzing a moderation between a categorical variable and a continuous one, type 2 homoscedasticity assumption should be one of the things that comes to mind that is part of your routine for going through that analysis. Okay, so finally, imagine you ran an MMR with a categorical moderator. So here, again, we're looking at an interaction between a continuous predictor and a categorical one. And let's say we didn't find any effect. So what are some possible reasons why? Well, 5 or 6 should come to mind just about immediately. Okay, so think to last time when we talked about MMR's power problem. And there are several things that go into power to detect, remember. So we have the first thing we have is the effect size in the population. That's usually pretty small for a moderation. So that is going to hinder our chances of finding. So it could be that you just didn't have enough power to detect because there was a small effect. The second thing that we can think about is imprecise measures. So that's one of the things that almost immediately comes to my mind. Remember the attenuation formula that we went over last week, and what it shows is that if we have imperfect reliability in any sense, we'll always observe a correlation that's lower than what it should be. So remember, go back and look at that formula and make sure that you understand that, and just know that measurement error always downward biases our results. The second thing that comes to mind, or third, I guess at this point, is range restriction. So anytime we have limited variance in any sense on the predictor or the outcome or the moderator, so any of the variables in the mix, we'll be less likely to find a moderation. So if you don't have variance, you can't have covariance. It's kind of a rule to hold on to and remember. So again, if everyone's scoring high on a variable or low or somewhere in the middle, then chances are that variable won't correlate with anything. So you can't correlate a variable with a constant, basically. And that's what happens with range restriction, is we're making a variable that should be highly variable into more of a constant, where everyone's scoring pretty much the same on that variable, and so it really doesn't pay to have it in the mix either as a predictor or an outcome or a moderator. Sample size. There are two considerations with this. First is your large or capital, I should say uppercase N, which is your total sample. And remember, again, it says approximately 250 to 300 is recommended. Unless you have a very large effect size in the population for this moderation, you can expect that it will take a large N to find it. Now, and then we have the subgroup lowercase n sizes. And remember that in order to maximize variability on a categorical variable, we need to have equal number of people in each group or units. So we don't want to have, if we have 3 organizations as our categorical moderator, we don't want to have 3 times as many people in organization 2 as there are in organization 1. That just reduces the variance in that variable, and therefore that means that it will be harder for us to detect a moderation. And again, if we don't have variance, we can't have covariance. Along those same lines, scale coarseness is another way to reduce variance. So the fewer options we give participants, if we give them just a 1 to 5 scale, that's not as precise and doesn't give as much fine-grained distinction as a 1 to 10 scale or 1 to 20 scale. So if we can increase those scale points without adding undue cognitive load on our participants, that's a really good idea. So scale coarseness reduces our chances of finding an effect. Type 2 heteroskedasticity. If we have that in our data, recall that will hinder us from detecting an effect that really does exist. Specifically, recall that if we have a group that has a very large n size compared to other groups, so let's say we have a group that has 3 to 4 times as many individuals in that group as the other groups, and at the same time, that large group has more error spread around the best fitting line than the other groups, that means that we're likely to commit a type 2 error. So that means that we need to check for type 2 heteroskedasticity whenever we have a situation with a categorical predictor and a continuous one interacting. And we would do that using alt-MMR and following the James and Alexander test if the homoskedasticity assumption is violated. We could have skewness or non-normality in our DV, and that would cause us to commit a type 2 error as well. We never want non-normality in our data, and we can correct for that by doing bootstrapped estimates, which is helpful. Finally, artificially dichotomizing or polychomizing our predictor variable or continuous variable is a very bad idea because it's, again, reducing the variability. So when you're thinking about doing client work, for example, or applied research, Oftentimes, people will do grouping variables. Well, they'll group age together, or something like that, where they'll either ask somebody's age and indicate what box you're in, or what age range you're in. Pardon me. Are you, 20 to 30 versus 31 to 40, 41 to 50? And so that's a way to polycotomize a continuous variable, which is not a good idea. You always have less chance of finding significance when you do things like this. So if privacy isn't an issue for your survey, I highly recommend that you keep all variables as continuous as possible rather than polycotomizing or dichotomizing them, either after the fact, before running the analysis, or as a survey question before you collect the data. When you're creating your survey, you're having people check a range rather than just indicating their actual age. Same thing goes for actual salary. That's on a lot of surveys, right, where we want your salary range, and for various reasons. That kind of way of collecting data is reducing your chances of finding any kind of significant result. So the more that you can have people indicate their real age, their actual age, their precise income, or just an estimate of their income, but they're giving one number rather than checking a box for range, that is helpful for finding significance. But you have to weigh that, of course, with the concerns about appropriateness and also privacy as you are collecting the data and then analyzing it afterwards.